Hi, welcome to the next step of the Cyanotype process. As you can see, I've got my kit here. Obviously the label came off, no big deal. Instructions, definitely important. Now the thing that I want you to do is just the solution A and solution B. You can really experiment with these other options at your, well, basically if you want to experiment with these options, you're welcome to. It's definitely not required for the class. I've got a few things here. First of all, a graduated cylinder. I assume most of you don't have these, and unless you're really into this kind of processes or doing garage chemistry, then that's probably not for you. But what will work perfectly is, since you need a 500 milliliter final volume for both of these reagents, is just get a couple of cheap water bottles. These are 500 milliliters, and so if you pour it until it's about full, then you know you're going to be pretty close. Now, the other thing that you probably don't have is distilled water. You can get this from the grocery store. It's usually, I'm going to say like 89 cents per gallon. Pretty cheap. But for the sake of the class, if you just want to use the water that comes in the bottle, that's okay too. You know, all these little things can add up. Now, obviously here I'm in a bright studio setting, and this is a little brighter than I'd like to normally work in. Now these are obviously light sensitive chemicals. They're not super light sensitive, they're not like the silver processes, but you still need to be a little bit careful with them. And one of the things that you do is wrap your clear bottles in aluminum foil to help to make them light tight. What else do we have here? An empty plastic, disposable, Ziploc or whatever container. Once we mix up our two A and B reagents, we're going to combine equal amounts into here, and then we're going to use that for painting onto watercolor paper. Gloves, of course. You can see here that I'm wearing an apron and I'm wearing dirty clothes. It's a splashy kind of thing, so the more careful you are, the less likely you're going to make a mess. But if you get these reagents on yourself, you are going to end up with blue spots. There's just no getting around that, and it doesn't come out. Watercolor paper is a really nice choice for this. It's got a little bit of a texture, which I assume is not showing up very well on the video, but just go to a Craft Warehouse or Michael's or one of those kind of stores and check it out. They're not too expensive, but they have a really nice weight to them. Having a little bit heavier paper is going to help you in the washing process. If you go with something too light, you're much more likely to ruin the paper when you're washing it. And we'll show that later on. Sorry about that loud noise with the microphone. So, of course, a marker for labeling things. Before I get to the mixing reagent parts, I'll probably get a second graduated cylinder out for the video. So let's see, everything out here. First step, put on gloves. Again, if you don't wear gloves, you're going to stain your hands, and you're going to have blue hands for a while. It definitely takes a while to go away. If you think Sharpies are bad, this is definitely worse. Now the Cyanotype process, it's been done on all sorts of different media. You could, if you wanted to do a huge large scale one, there's even been projects where people like paint a sheet with the chemical, and then they'll like lay on it and make little photograms. And you know, just really use whatever you want. The key is to know that whatever media you're using has to be able to soak up the liquid media, the chemistry, and it needs to be able to hold up to water, because it's going to need to be washed. If you don't wash these things thoroughly, what's going to happen is you're going to think, oh, this is beautiful, or maybe not, depending on how you like the process. But then it's going to continue to develop. So if you see yellow chemistry on your paper, that means you've not washed it long enough. We'll go into more of that when we get to it. Basically, for your kit, you have ferric ammonium citrate, arrowroot starch, potassium dichromate, and potassium ferrocyanide. Yeah, potassium ferrocyanide. So, let's see what we're going to do. Stock solution A, we're going to do the citrate, potassium dichromate, and the arrowroot are the ones we can set aside. I'm just going to put things on the floor here to get them out of the way. And the key is to try to get it all into here. Now, if you have a bigger container that you can mix in, it's going to be a little bit easier for you than trying to make a small little hole and get it into there. I'm going to stop the video for a second, get a little scissors to make it a little bit easier to pour. Okay, so I grabbed another graduated cylinder scissors and we're good to go here. First of all, I'm going to go ahead and wrap these up so that they're light sensitive. No, second thought, I'm not going to do that because that's going to make it harder. So usually I'd mix my chemistry state into the graduated cylinder, but since that's probably not the way you're doing it, I'll mix it in here and I'll need to be able to see where the line is. Ferric ammonium citrate. This is solution A. Obviously this is the light sensitive one. It's wrapped in black plastic. A little cheapy funnel here. Key is to get as much of the reagent into the bottle as possible, which without a funnel, and I really don't care to go ahead and ruin a funnel for this. I'm sure you don't either. So there we go, start pouring it in there. And you can see I'm still making a mess, so I'm going to need to clean up some of that. Now, it's probably not a bad idea to wear a mask when you're doing this. Either way, try not to breathe in any of the chemistry. Safety goggles, not a bad thing either. Now, if I would have been smart, I would have put another piece of foil underneath this to catch the loose stuff, but hopefully you can learn from my mistakes there. Call that good. I'm going to put a new pair of gloves on because I've made a big mess with this. And this is just distilled water. I'm not actually using a graduated cylinder here to measure, it's just easier to pour that way. In a past life I used to do cancer research, so using these kind of science tools makes me kind of happy. Reminds me of the old days in the lab. So get it all together, mix it up well. Add that last little bit of water. And then we call that good. I'm going to grab a piece of paper towel. Paper towel is another important one for you to have on hand. Definitely if you are trying to mix up the chemistry this way, it's going to be a messy process. There we go, we'll call that good. We're going to call that reagent A. And it's important to cover up the top of the cap too, because that actually does let light in. You just obviously need to remove that for when you're pouring. One of those brilliant moments here from your instructor. Call this A. Of course, all I have is non-stick aluminum foil. It doesn't make the best labeling. I'll probably have to go back and add a little bit of tape to that. Okay, so reagent B, it's going to go a little easier because it's not nearly the volume. I'm going to learn from my past mistakes, put some foil down on the ground. Potassium dichromate is not this one. Yes. B, potassium ferrocyanide, definitely the right one. I was just skipping ahead. So here we go, this is what reagent B looks like. While reagent A was nice, bright yellow, this is kind of a muddy orange sort of color. Make sure it's mixed up very well. Wipe that off. Wrap it up, call it B. Now, I'm going to pause here for a moment while I clean up my little work area and go on to the next step. Okay, so next step. When you mix these reagents, obviously it's important that this would be wrapped up in aluminum foil too. The reagent kit tells you how to use the other chemicals in the kit if you so desire, and really I encourage you to explore that if you want. I'm going to keep this as simple as possible for the sake of the project, because obviously I expect very few of you will actually be doing cyanotypes on a regular basis. So no need to go into too much detail. So here we go, rip off the first piece of paper. Go ahead and rip off this other piece too. Now, you can see I put down some foil underneath this. It's a messy process. And again, whatever surface you're using for this, make sure that it's protected or that it's something you don't care about. Here I've just got an inexpensive piece of pine from Home Depot, I guess I got it from. And I use it for these kind of things, so it doesn't really matter if it gets dirty. If you're using anything that is anything of importance, make sure that you have it covered and well protected. And I'd actually recommend that if you're using foil underneath it, that you go quite a bit further, because when you're painting this on, it can splash it. So the next step is to use equal amounts of reagent A and B, and I'm just going to do a few of them here. And again, the instructions say that you get 2 to 4 hours once it's mixed. My experience is it's probably a little bit more than that, but obviously these these instructions here are meant to be on the most conservative side. So I'm just going to go ahead, I'm going to use about 30 milliliters of each, and you want to get this as close as possible to being the same, but obviously, again, I don't expect you to have graduated cylinders or any sort of precise measurement tools that you can afford to get dirty with chemistry. You definitely do not want to use any food measuring devices for this. So that was B, this is A. And do one more shake. And you can see how it's turning into a kind of a greenish color, hopefully. Now again, this is brighter than it should be. Go and work in a room that doesn't have any bright windows, and just turn the lights off. You know, having reflected light from the windows is probably going to be okay for this. The dimmer you have it, the better, and of course you want to make it so you can see. Now, part of the process here, in the example of the portrait that I posted last week, shows you how you can use the brush strokes to make it a part of the image. So the options here are either to completely, as much as possible, uniformly cover the paper, and these little cheap, 50-cent brushes are perfect for this, or use the brush strokes as part of the design. So when you're doing this, go all the way across, right to left, and then go and paint top to bottom to make sure that you have a uniform coating. Now, again, you can't use this until it's completely dry, and so the easiest thing is, if you have some room in a drawer, just kind of tuck it out of the way. If not, then a hairdryer can do a just fine job. So I'm going to finish this one up here for the video, and then I'm going to make as many as I can with the reagents I've already mixed up. But I'll do that part off video, but I'll show you how they turned out after, when it comes time to start making the contact print. So there we go, pretty even. The next ones I make, I'll be a little bit more careless with the way that I paint it on, so you can see how that might work. Let me know if you have any questions, and we'll show you the next part soon. Just to give you an idea, this is about the normal lighting that I would usually use. I've got one fluorescent light on way in the background, and I've got a couple of glass block windows over here kind of lighting things. It's very indirect light. This kind of thing you can work pretty safely without worrying about ruining your chemistry. So the rest of the papers that I'm using here is a much thinner quality paper, and I'm using this specifically so that you can kind of get an idea for how the different kind of papers might look, and how it is to work with them. So the more even you put the chemistry on, the more even your print's going to be. And again, take into consideration different sort of aesthetic things that you might reasons that you might not want your prints to be very even. That one can take a long time to dry. Okay, we're going to call that good. Let these dry. And once they're dry, then we'll go ahead and make some contact prints.